Hi, this is Leetcode question. Take care of each character from left and right. This is the second question of weekly contest 325. You are given a string S consisting of characters A, B, and C and a non-negative integer K. Each minute you may take either the leftmost character of S or the rightmost character of S. Return the minimum number of minutes needed for you to take at least K of each character, or return -1 if it is not possible to take K of each character. So here we have a string that has 8 characters, and all of these characters are either A or B or C. We can remove character from the leftmost or the rightmost, and we need to at the end to remove at least K characters of each type A and B and C. For example, if we remove this character, then this, then this, then this, then this, then this, then this. By doing that, we removed 3 A's, 2 B, and 2 C's, and so we removed at least 2 characters of each type, and this cost us the number of removed character, which is 7. So 7 minutes, but this is not the optimal solution, as we need to return the minimum number of minutes. So a better way to do that is to remove this character and this and this and this and this and this, and by doing that we removed 2 A's and 2 B's and 2 C's, and this cost us 3 minutes in the left side and 3 minutes on the right side. So in total it cost us 3 plus 3 equals 6 minutes, and this will be our answer for this example. How can we solve this problem? First of all, we need to create a vector. Let's call it prefix, and this vector contains 3 arrays: 0 for character A, 1 for character B, and 2 for character C. So this is for A, this is for B, and 2 for C. And each of these 3 arrays has the same size of the character, or the string size. So the index will be 0, 1, 2, 3, 4, 5, 6, 7, and this is 8 characters. And this table will contain the count of the characters when iterating from left to right. Initially all the values are 0, and we start at this index A, and so we update the value at index 0 for array 0, because it's the array for A character. So increase it by 1, and the other value remains 0 for B and C. Then we move to the next character, which is B. So we increase the value for P. 0 plus 1 is 1, and A and C remains the same. Then we have C. So we increase the C by C is 0. We increase C by 1, so we have 1, 1, 1. Then we have A, so we increase A by 1. 1 plus 1 is 2, 1, 1. And This means that at index 3 we have 2 A's so far, 1 B and 1 C. So at this index we have 2 A's, 1 B and 1 C on this segment. We continue our iterations. So next we have A, so increase A, 3 1 1. Then we have another A, 4 1 1. Then we have B, so increase B, 2 4 1. Then we have C, so 1 plus 1 2, and B and A remains the same. Then we need to create another table for prefix for suffix, and again it will has 3 arrays, 0 for A and 1 for B and 2 for C. And this array, this time we will iterate from right to left. So we start from C, so increase the value for C by 1, so 1, and A and B are 0. Then we have B, so increase B by 1, so 1 0, and C remains the same from the previous index. Then we have A, so 1 1 1. Then we have A, so increase A by 1, this is 2 1 1. Then we have A, 3 1 1, and this means that at index 3 here, 0 1 2 3, this index up to the end, so in this segment we have 3 A's, 1 B and 1 C. We continue our iteration. We have C, so C 2 1 3. Then we have B, so 2 2 3. Then we have A, so 2 2 4. And now we have the two tables ready. What we need to do is to iterate over the string or over all the indexes. So we have index 0, and for every index we will check the three values, 0 for 1, for A, and 1 for B, then 2 for C. So we start at index 0. At index 0, at the prefix table we have the value 1 for A, so we have the value 1 for A, and so we need to search from the remaining part of the string, which is from index 1 up until the end for this array. So we need to search on this segment on the suffix to see if it has values for A which equal K minus this count 1. K we know it's 2 minus 1 equal 1. So we need to search for the first occurrence of the value 1 on this table, and here we search from right to left, and the first occurrence of 1 is here. So this is at index 5, and this means that this segment has 1A, and so we have index variable, we store on it the index 5. Then we do the same for B. B we have the value 0, so we search in the suffix array for k minus 0 equal 2, and we do binary search on this array as it's sorted. The suffix array and the prefix array are sorted. The suffix sorted from right to left, and the prefix array is sorted from left to right. So for B we search for the value 2, and the first occurrence for the value 2 is at this index, which is index 1, and so we update our index to the minimum of 1 and 5, so the index is 1, because 1 guarantee that this segment has the solution for A and B. Then for C we have 0. Again we search for k minus 0, 2 in the suffix array, and the first occurrence for 2 is here, which is at index 2, but 2 is not less than 1, so our final index is 1, and this means that for our answer we store the value that equals to the segment on the left, which is our index in the iteration. The prefix here we have this segment, and in the suffix we have from index 1 up to the end, so the length of the prefix 1 is I plus 1, which is 1, plus the length for this segment in the suffix is the number of characters 8 minus 1 equals 7, so 1 plus 7 equal 8, so our answer will store 8. Then we move to the next index in the prefix table, and we do the same for A and B and C. So for A we search for in the suffix array in this segment for value k minus 1, and the length of the prefix segment will be this, and if we get better answer we will update it, and we do this for all the element. Then after we done, we will do another loop, but this time over the suffix array, so we will loop over the elements one by one. So imagine if we are at this index 1, and at this index for A we have the value 3, and this means that for on this segments we have 3 A's, and so we need to, so this is enough, no need to search for in the prefix sum, because this is greater than or equal k. But if we are at this index 5, and we have here for A equal 1, so we need to research, because this has 1 A, we need to search in the prefix in this segment from 0 to this index minus 1 to see if we have k minus 1 equal 1 A's, and the first occurrence for this is A, and so this segment has 1A, this segment has 1A, and this is a solution for A will be the length of this, which is 3, plus the length of 1 is 4, and we need to check for B and C and update our answer of if it's less than the answer. And the time complexity of this is big O of n log n, because here we will do binary search and we need to iterate over every index. Let's look into the implementation. So here we created the two vector prefix and suffix, and everyone is of shape 3 for the arrays 0, 1, 2, and of length n, and we fill the prefix table, then the suffix table. Then we have to iterate over the indexes from I to n, and for every index we need to iterate over the three arrays 0 and 1 and 2. If the prefix is greater than k, then it's sufficient, no need to search in the suffix vector. But if it's less, then we have to do binary search, and we look for the value k minus prefix value. And if we did not find the value, this means the whole array does not have a solution. We return -1. Now we take the index that has this value, and this index should be greater than our current index is the prefix. So if we are at this index and the suffix return this index, so this is not good because this is our segment, so we need complement for it. We need to search for this segment. So if index less than or equal I, this means this is not good. And here we store our answer by updating the length for the left segment in the prefix, which equal I plus 1, and the length of the suffix segment, which equal n minus j. And now we need to iterate again over the suffix table. For every value we need to search in complement in the suffix array, and we update our answer based on the results.